Okay, speed after 65 seconds. Oh man, that means, okay, wait a minute. A rocket moves upward, then starting from rest with an acceleration of 36.2 meters per second square for 65.0 seconds, at which time it runs out of fuel. Okay, wait a minute. Sounds like very simple. Okay, so they are looking for the final velocity, right? Which is v. Okay, so v equals, you remember? Oh, that's right. So v equals, which is, you can use f. Okay, final velocity, which is initial velocity plus at. Oh, very simple. So in this case, they are looking for the speed after 65 seconds. Ooh, so initial velocity was 0 because rest, right? From rest. That means 0 plus. That means we don't have to worry about this one. Okay, so now at, which a was 36.2. 36.2, okay, meters per second squared times, okay, 65 seconds. Okay, 65, okay, seconds. Okay, that's why you can reduce this one by 1s right there, 1s right there. That's going to be automatically, that's going to be speed, right? Which is velocity. So all you got to do, just to multiply. That's it. You just calculate this one, so which is 2,353 meters per second. Wow, this was going to be so fast. That's why we call rocket. That's right. So answer for A, 2,353 meters per second. Meters per second. Same thing. This question again, so you have to think this one twice. Okay, two different things. Okay, one, from the ground, okay, it goes up to a certain point, just like that. Okay, then no more fuel. Okay, so it's going to be going by itself. Okay, so automatically. See, just like that. So first of all, so we have to find out velocity on this point. Okay, so now velocity on that. Okay, so I'm going to call v1. How about that? Yeah, we had that one already, 2,353. Okay, so I'm going to write 2,353 right there. That's the speed. Okay. Then after that, this is going to go by itself, right? So automatically until this speed is going to be 0, right? Okay, so final velocity is going to be, actually just a v. It's going to be 0. So in this case, I'm going to call this bottom one, so S1, which is the distance. Okay, or D1, doesn't matter. Okay, so S1 right there, so S2 right there. Okay, so if you're looking for S, like a distance, okay, so, I'm going to do S1 first. How about that? Okay, so distance is, you remember this? That's right. V0t, okay, plus half at squared. That's it. In this case, from rest, so this is going to be 0, so initial velocity. Okay, that means, hey, all you got to worry about, so half A was 36.2, okay, 36.2, then t squared, which is 65 squared, right? 65.0 squared. That's it. This is going to be 76,472.5 meters. S2, exactly the same thing, right? But the V0, which is 235, that's it. In this case, V1, okay, so but we count that as V1, okay, initial velocity. So 235, okay, So as soon as you see this one, 235, then t, right? T. But the problem is that we have no t. That's why, oh, that's right. Yeah, we can find the t first, then we can do it. But, okay, that's why we have different, what? The formulas. That's right. So we're going to pick up the different one. So then we're going to pick up maybe the last one, which is, I showed you, okay, 4 formulas, right? But the last one was 2, remember, 2as. Instead of a in this case, okay, we're going to use the gravitational acceleration. That's why we're going to use g, okay? So 2as or 2gs equals, you remember this one? Okay, so v squared minus v0 squared. Okay, so we're going to use that one. So obviously we are looking for number 2, so I got to put S2 right here. Okay, then I'm going to move this 2g, okay, divide by 2g right there, okay? So 2g. That's it. So all you have to do, so we just plug them in, right? Okay. Just like this one. Okay, what was the initial velocity on that point right there, S2? Okay, initial velocity was 235, but final velocity was 0. That's why 0 squared, which is negative in this case. Yeah, that's right. 0 minus 235, okay, squared over 2g, which is 2 times g is negative 9.8. Okay, because this one is going up. So finally, we have the answer. 2,817.6 meters. That's it. So I'm going to write this one, answer right there. So distance, okay, 2,817.6 meters. Okay, so maximum height, all I have to do what? Okay, I got to add these 2 numbers, right? So S1 and S2. That's it. So together, 7, 9, 2, 9, 7, 9, 2, 9, 0.1 meters high. Very, very high, right? Okay, let us see. Oh, man. So let us see question C. Okay, maximum downward speed. That means, oh, something is coming down all the way down to the ground. That is the maximum speed, right? Okay, so which is, oh, final velocity equals initial velocity plus AT. Oh, this one is a very simple one. Initial velocity was 0 because this one coming down all the way to the bottom, which is, oh, we use gravity. That's why G, which is 9.8 times time. Now we realize that, oh, wait a minute, no T. See, no time here. Okay, that means, so we picked up wrong formula. That means we gotta go to the different one. That's right, without time. So this is happening all the time. Okay, wait a minute. Oh, then we're gonna use this one. Oh, that's right, 2as, which is 2gs. Okay, s is distance, equals final velocity squared minus initial velocity squared, right? Oh, that's right, this one has no t. So in this case, okay, v0, which is the initial speed way on the top, it was nothing. That's why 0. Then, oh, we are looking for final velocity, v. So v equals, you know, that square root. Okay, ignore the positive negative. Okay, 2gs, okay, 2. Then g is 9.8. Then s is the distance, right? Oh, distance together. That's right. So maximum height right there. So 79290.1. Then you just put square root sign. That's all you have to do. The final speed, maximum speed, 1,246.6 meters per second. Wow, so fast. Now we are looking for what? Okay, question D, total time in air. Okay, we are looking for total time. That means, oh, that's right. We have three portions, right? Three different parts. Okay, T1, I'm going to call T1. This one, I'm going to call T2. Okay, what about coming down all the way down? That's a T3. How about that? See, T3. Then we're going to get all this one, then add everything. That's it. Okay, T1. Oh, that was given right here, right? Okay, 65 seconds. That's it. We don't have to worry about that. Okay, 65 seconds. So T2 and T3, oh, that's right. So we know initial velocity, we know final velocity, then we know gravitational acceleration. So we better use this one, right? Okay, so what about V final equals V initial plus AT? Oh, which is in this case GT. Ah, great. So from this, we can say T2 equals, okay, then, hey, we're looking for T2, right? Okay, then means V minus, okay, V minus V0, okay, over G. That's it. So now, T2, so V was, what was it? 235. That's right. Okay, 235 minus, oh, V0. Oh, in this case, V0, I'm sorry. Okay, so final speed was nothing. Okay, all the way up there, right? All the way up there, it was 0. 0 minus, that means this is going to be negative. Divided by, okay, gravitational or acceleration, negative 9.8. Wow, that's it. Okay, let's go. What about 3? That's the same thing, right? So, final velocity minus, okay, final velocity was what? That's right, maximum downward speed, which is 1,246. That's it. 1,246.6 minus 0, which is initial velocity in this case was 0. So divided by positive 9.8. That's it. Okay. So total time equals 65 plus 24 plus 127.2 seconds, which is 216.2 seconds. That's it.